Formulas are equations that are kind of a rule that works no matter what for a specific relationship between various things in math. So, for instance, if we have a circle, the circumference of a circle is, so circumference is the same thing as 2 times pi times the radius. Now, 2 is a constant, pi is a constant, so this only depends on, the radius you're given or the circumference that you're given. Now you can just start plugging in values for r. Like, let's say you have a circle, the radius is 5, and then we want to find the circumference of that circle. Well, you just plug in 5 into this formula, and then you do the math, and you get 10 times pi, 31.41, and that's probably good enough. Round it to the nearest hundredth, so it'd be a 2, because that next digit is a 5. That's cool and all, plugging in values into formulas like this. But what you can also do, solve for certain values, solve for certain variables before you do any plugging in at all. So here I'm going to solve this formula for r, which means I want r all by itself. So you do the same thing as our properties of equality, because this is still an equation. Yet it's not going to look like we did anything, because here we're like combining like terms and canceling things out. Here it's not going to look any different as far as like the symbols within the formula are concerned. But the benefit of this is knowing that once you start plugging things in, you know that it's immediately solved for the thing that you don't know. So let's say you were given the circumference, but you don't know what the radius is for whatever reason. Then here you would plug in the circumference. Circumference is 10 pi 31.42. Find the corresponding r for that circle. C is this. Now remember, this pi is like a symbolic constant. Depending on how far you round it to, you can go ahead and replace this with whatever you want it to be for that problem. I lost my train of thought there. 1, 5, whatever. Whatever you're rounding it to. Sure, let's just round it to the 10th. You could have just as easily plugged in the known c into our original circumference formula. Then we would still have to solve for r, but it's good to know that you can do those properties of equality even if you don't have all those things, if you don't have things that are combining like terms and whatnot. You can just move things around anyway, because again, variables can be anything, but they have to be numbers. You'll run into something called, it's not really a definition, but you'll see it as in terms of. So it'll be like x in terms of y. What that means is we want x isolated. And then on the other side of the equality are going to be, constant terms, whatever, and they're going to have terms with y in it. If they're constant terms, obviously they won't have y in them, but let me give you an example. -3. And I want to solve this x in terms of y. Solve for x, and in terms of y, there's going to be terms, there's going to be things on the other side. It's going to look messed up, it's going to look garbled up, but there's going to be y's in there. There's no x's. That's the idea. So I'm going to add 3 to both sides. Y plus 3 equals 2x. And then divide both sides by 2. So here we have x equals y plus 3 over 2. These two equations are the exact same equations, they just are solved for different variables. And that's what it means by in terms of.